Welcome back. We are going to be going over water, a limited resource, which is chapter 13. Okay, so we're going to look at different places and different examples of how water is a limited resource and really all over the world how this resource is not being used sustainably and different ways that this resource is threatened. So obviously water is a very important resource. Our planet is known as the blue planet. And if you look at our planet in comparison with the other planets within our galaxy, you can see that it really reveals a different color, shade. It looks because 70% of it is water. So it is our blue planet. Water has a tremendous effect on the planet. It shapes the continents. It moderates our climate. It allows organisms, including us, to survive. And even if the planet is known as a blue planet and we have plenty of water, right? Only 97% of that water is salty and not usable. So that leaves us about 3% of fresh water, which is what is necessary, right? And of that fresh water, most of it now is frozen. So we don't have much available to us. We really rely on the hydrologic cycle, what we have in reservoirs, dams, and our groundwater. So that's really what we're relying on. And when we look at how climate and precipitation is distributed through the planet, we know that different places have more availability of water, right? Naturally, they're going to get more rainfall, so their water per capita is much higher. Places like Canada versus these really, really dry, arid places of the world where they just don't have that rainfall. So our water is not distributed evenly. And if you watched that video last week, it really did a great job of explaining the crisis that we are in now in terms of water availability. So the hydrologic cycle, this is just kind of a review, a refresher. You have water that will evaporate, condense, and then return back to Earth as some form of precipitation. So this is really like that movement, that continuous interchange of moisture between Earth and the atmosphere, right? So keep that in mind too. It's that unending circulation of our planet's water supply, and we refer to this as the water cycle or the hydrologic cycle. So here is that water cycle, the hydrologic cycle, a little bit more in detail. So we have evaporation. Obviously, evaporation mostly happens over the oceans. And then you have condensation, you have wind that move those clouds that carry all that water over land. Then in precipitation that happens over land, and most of that water runs off back into the ocean. Some of it is stored in lakes, and a lot of that is stored underground too. So different places have different geological makeups, and so different types of soil are going to be able to absorb more water and act as a better aquifer than other areas. So it really depends on the makeup of the area that you're looking at in terms of their soil, okay? So here is what I kind of already explained. It's just another slide for it. Water continuously circulates through the environment, from ocean to atmosphere. Okay, so here's a breakdown of our water, right? So about 97.5% of our water is in the ocean. So about 2.5% is fresh water. And so that's the key here. This is what is available to us, right? And of that, about 1.9%, 97% is frozen. So we only really have about 0.8% around there. No, yeah, a little less than that. Just around there, right? And these are really rough numbers. And some places will tell you it's exactly 98% seawater, 97%. So around these numbers. It just really depends on the source that you get it from. I have two different books that I teach from, and one will say 98% is ocean water, and one will say, like this one is 97.5%. But what I do want you to see is how little is available. Not very much, right? So here's another breakdown of that. Seawater or ocean water is about 97.5%. Fresh water is 2.5%. Of that 2.5, a lot of it is frozen in our ice caps and glaciers for now, right? So when those ice caps and glaciers melt, they don't melt as fresh water. I mean, they melt as fresh water, but they go into the ocean. So there's no way of capturing that. Now, as climate change accelerates, as temperatures get warmer, as more of our ice caps begin to melt, this will disappear, right? This will be a smaller number, and then our ocean water, it will be a larger number. Here's just another explanation of the breakdown. Okay, so about 98% of Earth's water is in the ocean. Then you have surface water, okay? Surface water is just what it sounds like. It's just a term that describes water on the surface of Earth, right? And it can be in different forms. So it could be streams, rivers, lakes, ponds, reservoirs, wetlands, swamps, all these things, marshes. These are all different types of locations that we would find surface water. Another important term that I want you guys to know is drainage basin or watershed. So this describes the area of land that is drained by a single river or stream. So this would be a drainage basin. So like if you look at the topography or these hillsides, right, and you see all the water draining down to the foothills, or, you know, obviously if the water that falls on top of the hills or mountains drains to the bottom, right? So this is just the technical term for what you're witnessing. Very simple, okay? A drainage basin. You have one basic or main river or stream, and then you kind of have these little flows. These other tributaries is what you call them. So these would be like tributaries. And you would also, like if you were there hiking there, you'd be like, okay, this is a stream, right? But when you're looking at it as a drainage basin, you would call these tributaries and then the main stream or river, okay? And so it's just the natural way that the water flows down a mountain, hill, any slope, right? We would call that a drainage basin or watershed. When we look at groundwater, so groundwater is a really important source of fresh water, of drinking water for a lot of places on Earth, okay? However, it is a non-renewable natural resource only because we are using that groundwater in a way and too quickly we're removing that groundwater before it can recharge. So that's how we say that groundwater refills. Instead of saying refilling, we say it's recharged. Okay, so that's just a different way of saying things. So that you have different types of soil, right? Different types of rocks and soil, and some are more porous than others, and they absorb water a little bit better. So something like an aquifer, this is a geological feature. They're underground reservoirs that are either confined or unconfined. So a confined aquifer would be surrounded by 2 layers of impermeable clay. You guys don't need to know all these details, but it is important for you to understand how important groundwater is. And I think last week when you watched that video, I kind of did a good job of explaining a little bit. You have water that percolates and seeps underground through cracks and spaces in gravel and sand, and where it accumulates, we call that groundwater. Groundwater flows through permeable sediments of rocks slowly, typically covering distances of several millimeters to a few meters a day. So these are underground formations that collect and store water. Most groundwater is considered to be a non-renewable resource because it takes hundreds, or it has taken hundreds or even thousands of years to accumulate. And we know that we're not using that in the same time frame. right? We are in a desperate need for water. So of course we're overusing these aquifers. So the recharge of these aquifers is particularly slow, especially these confined aquifers. The cryosphere. Yes, we're talking about the hydrosphere and water as a resource, but it's important for you guys to know and kind of learn a little bit about the cryosphere. This is the ice part of the hydrosphere. It's divided between ice on land and floating ice, and that ice on land would be a larger portion. So a couple different formations, and I'll have pictures on the next slide, but you can just write this down for now. You have ice pack, ice shelf, ice flow, iceberg. So you can pause it and write this down. But let me show you what these are, right? So this would be an ice pack here, an extensive mass of floating ice. This would be an ice shelf here, a massive portion of continental ice that projects over the sea. This would be an ice flow. A large flat mass of ice that breaks off from a larger portion and floats independently. And then this here would be an iceberg, right? An iceberg is a chunk of floating ice that breaks off from an ice shelf. All forms of oceanic ice are composed entirely of fresh water because the salt present in ocean water does not incorporate into the crystals when water freezes. Permafrost is another important part of the cryosphere. So this is found in really high latitudes. And we know that soil contains moisture, right, naturally. However, in places where temperatures are very low, so very high latitudes, temperatures have to be low enough all year long, that soil, that moisture in the soil stays frozen. It's permanently frozen subsoil. So we call this permafrost. This is a relatively small portion of the world's ice that is considered permafrost. It's widespread in very high latitudes like Canada, Alaska, and Siberia. And you'll say, well, that's only the northern hemisphere. That is true because in the southern hemisphere at those latitudes, there is no land. So that's something to consider, right? So Canada, Russia, Alaska, all these portions here, parts of Europe, Sweden, Norway, Finland, all these very, very high latitude, ooh, this is dusty, high latitude areas do have permanently frozen subsoil. And just like with almost everything that we talk about in this class, unfortunately, because of climate change, there is something happening to the permafrost, right? That's kind of where everything leads to. So within that permafrost, you have like organic matter, right? And anytime you have like dead organic matter, like it could be plants or animals, there's going to be microorganisms that are decomposing that organic matter. Now, because this is permanently frozen subsoil, those microorganisms naturally are going to burp and release methane, right? When they're breaking down that organic matter, that's what they do. They release methane. However, because it's permanently frozen subsoil, that methane becomes trapped within that permafrost. So that permafrost contains a lot of methane bubbles and CO2 bubbles too, trapped, frozen. So we don't have to worry about them, but there is the issue of our permafrost melting. So in turn, what happens as our permafrost melts, it's starting to release these extra bubbles of greenhouse gases, right? And so CO2, yes, that's a terrible greenhouse gas. So you have a molecule of CO2 being released into the atmosphere when that permafrost melts, but you also have methane. Now, methane is 32 times more potent as a greenhouse gas than one molecule of carbon dioxide. Okay, so not only do you have CO2, but you also have methane. And so it is incredibly dangerous as a fossil fuel, as a greenhouse gas. So as those methane bubbles are released, as that permafrost melts because of rising temperatures, because of climate change, right? You have those molecules go up into the atmosphere, and now they trap more sunlight in the lower portion of the atmosphere, which produces more warming, which will melt more permafrost and release more methane. So it's like this runaway effect. Does that make sense? So this would be a positive feedback effect. One change is going to incur another change. And that's the thing with climate change. A lot of the times we think we see the full picture, but we don't actually see the full picture yet. We are starting to discover these positive feedback effects, or these other, this tipping point, right? We're at the tip, but it's kind of like we don't see over the edge quite yet because we're not able to really see the entire effects of our climate warming, okay? So it can also affect buildings. So you have that permafrost that was once stable. When it's frozen, it acts as like a good foundation, right? However, when it melts, if there are buildings or monuments there, it does cause like the land to become like more, not liquid, but it's something like liquefaction. So you have these buildings and monuments do suffer because of the melting of permafrost. All right, water use and resource problems. So, you know, when you think about water as a resource, the problems tied to water can fall into 3 different categories. So you either have too much water, not enough water, or contaminated or poor quality, right? And so a great user of water worldwide is agriculture. It's specifically animal agriculture, and I think I've drove this point home pretty well this semester. Animal agriculture is probably one of the worst things to the environment. And you know, there's a lot. You can't really just blame one thing and not the other, but animal agriculture is extremely harmful, and the types of agriculture is extremely harmful. We know that animal proteins have a huge water footprint, especially cows, right? Because they're a huge animal and it takes a lot of water to grow feed for that animal. But there's other things that have a really high water footprint, and that's what we would call it. So like for instance, coffee. Coffee has a high water footprint. It takes 130 liters of water for 1 cup of coffee. And you might say, why? I mean, a cup of coffee is a cup of water, right? But think of those coffee beans and where they're grown, how much water it takes. And we're starting to see more places that are growing coffee where they shouldn't be growing coffee. And that's just one example. Or like almonds. Almonds have a high water footprint, and we're growing almonds here in California. Is there enough water for almonds in California, or pomegranates, pistachios? I don't think there is, right? Or beer, unfortunately, has a high water footprint too. I'm a huge beer fan. It takes about 74 liters of water for a cup. What's a cup, right? A large cup of beer. So like a quarter-pound burger, it'll take 1,600 liters for a quarter-pound burger. So being very aware and conscious of your water footprint and whatever it is you're purchasing is important. You know, I'm not pushing for you to be a minimalist or have zero impact on the environment, because that's just set up for failure, right? But if you can move forward thinking I'm going to have a lower impact, then it's easier to live that way, right? You're striving not for perfection, but for progress when it comes to things like this. So it's also almost like if you say, oh, I'm going to cut this cold turkey, you're destined to fail, right? But if you say little by little, I'm going to be more conscious of things I buy. Maybe I'm not going to eat cow or beef anymore. Maybe I'm just not going to eat pork anymore. Whatever it is, right? It's just like one little step. It's one thing, because it's really difficult to live a life and have zero impact. And if you say I'm going to live my life with zero impact, there's more chances of you failing. But a lot of us living our life with less impact, that makes a bigger impact, bigger difference. Does that kind of make sense to you guys? So do one thing, right? One thing can really help. So I'm not, saying you should never eat meat again. That would be really nice. I mean, I haven't even done that, but it's you personal. Like, what is your personal choice? What are you going to do to help this movement? And I kind of went off track there a little bit, but it is important for you guys to know what you're purchasing and what the water footprint of that product is, or what the carbon footprint or ecological footprint of pretty much anything that you are purchasing, because as a purchaser, you do have the power. So when there is too much water, the issue of too much water, sorry. Early civilizations like Egypt developed near rivers that spilled over. So this is more for civilizations that are older, and that, when you settle in a place, you settle near water. Flooding resulted from system interactions among human activities and natural phenomena. Modern floods are more disastrous in terms of property loss than those of the past. So modern floods today are more disastrous. Because humans often remove water-absorbing plants from soil and construct buildings along floodplains. All that is the area bordering a river. This is going to lead to more floods. So a great example of this would be the Mississippi River, right? During that hurricane of Katrina, we know that the levees breached. But also, anytime you settle along a floodplain, it is more prone to flooding. And all those plants that are naturally found along floodplains are not there to look pretty. That riparian ecosystem has a job, right? It's to absorb a lot of that excess water. So when we remove it, when we channelize it, when we build homes, roads, whatever it is going to have an effect, because those water absorbing plants are very, very necessary. When woodland areas, for example, along a river are cut down, the area cannot hold water nearly as well. Plant protected soil absorbs more excess water after heavy precipitation. When an area is developed for human use, water absorbing plant cover is removed. Buildings and paved roads do not absorb water. So remember, I showed you the video on the LA River being channelized. The channelizing back then was to control flooding. Many rivers are channelized, straightened, deepened. Now scientists are recommending to let rivers naturally meander. So you had the Mississippi floods. I'm kind of getting ahead of myself, but here's a picture of surface runoff and the difference between surface runoff in a non-urban or pre-urban area, here you go, versus an urban area. So you have precipitation, and almost 50% of it is naturally just absorbed, right? And 10% of it is just surface runoff, versus an area that is urbanized, paved, channelized, whatever you want to call it. About 32% is absorbed in groundwater, and 43% is just straight surface runoff. So you see how that natural that natural landscape is important. It's necessary. So here are floodplains. You can either channelize a river or let the river naturally meander. Okay, those are two different options. The Mississippi floods of 2011, that's kind of what I was getting into. You have heavy rains in the upper flood plain area, and you had elaborate flood control systems along the river constructed by the Army Corps of Engineers. But during Katrina, again, this is just kind of a repeat of what I was talking about. Those levees did breach, and so all the green would be floodplain area or places prone to flooding. Another issue with water as a resource would be too little water, right? This is something that is easier kind of to talk about, because when we think of water as a resource and issues surrounding water as a resource, you don't typically think too much water, right? But too little water. So we see that in arid lands or semi-arid lands. Arid lands would be deserts, and semi-arid lands receive more precipitation than deserts, but they are subject to drought. So they're still dry, but they're still going to receive more rain than a desert, but they can still be considered arid. Okay, irrigation is important for agriculture. Population growth in arid and semi-arid regions calls for more water. More people need food, so more water is diverted for irrigation. For example, we were in a drought, and I think technically we still are, but a few years ago we were in a very, very long drought. No one knows how long droughts will last, but previous droughts like in Arizona do last up to 20 to 40 years. Okay, so droughts can last up to 40 years. We might be kind of out of the drought now, but we are never really at the amount of rainfall we should be getting. Does that make sense? And then I'm talking about here in Southern California. So when you do irrigate land in arid places, it does have an effect on the land itself. So it can cause desertification, it can cause the topsoil to become very poor quality, the topsoil. It can cause a lot of stressors on the surrounding groundwater. So there's a lot of problems with growing crops in areas that are dry. And so here in California, we grow a lot of crops. California pretty much supplies the United States with agriculture, not with the entire agriculture, but it is a huge part of the agriculture for the United States. And people say, like, why are we growing things here in California if we don't have water, if we're dry? Well, because we have the perfect sunlight, you know, so we're taking water from other places and bringing it to California, not really to, well, yeah, for the population, but a big part of the reason why that water is diverted is because of agriculture, right? So like in the Sacramento River Valley, we are growing things like rice. Here in Southern California, Central California, we're growing things like pistachios, almonds again, and all these are extremely water intensive crops. So that leads to aquifer depletion. So this is an excess removal of groundwater, lowers the water table, can empty aquifers, and pretty much eliminate them as a water resource. So if we're taking all that water out and there's no law about taking groundwater out, or you have much more money as a farmer than your neighbor, which is a smaller farmer, you have the resources to get that water out because it costs money to take out groundwater. If you have that money, there is really no law to say that you can't take what's under your neighbor's lot or under your neighbor's land. So there needs to be a change in water law, especially groundwater law. And I will have a video on that. It's really interesting what's going on here in California and with Paramount Farms and the Resnicks. So I'll have a video on that. I think that's what this link is here. Saltwater intrusion can also occur when you take out too much groundwater. This occurs obviously along coastal areas. With groundwater is depleted faster than it is recharged, you do have the salt water that comes in through that water table. So this eventually will damage it, like that groundwater that is there is not usable if that salt water comes in. This also occurs in low-lying areas due to sea level because of climate change. Eventually that well water that humans relied on is too salty for consumption. So that would be saltwater intrusion. Pollution, that's another form of issues when we're talking about water as a resource. And the reason I'm showing India is because almost, I want to say every river in the subcontinent of India is polluted, and some of them are extremely polluted. So we know India has very high population, so that's a big reason for their pollution of their waterways. There's just too many people. It's very difficult to kind of redo the infrastructure of their water systems there. A lot of places do not have toilets, so there is a lot of issue with pollution there. The Yamuna River. This is a highly polluted river in India. Water flows from the Himalayas, and as it comes off the Himalayas, we know it's clean, clear water into the Ganges Delta. By the time the Yamuna exits the city, it is lethal. So the pollution point is to a deadly point. It is a toxic cocktail of sewage, industrial waste, and surface runoff. And a lot of the reason for this is because of urbanization. About a third of Delhi's 17 million residents are not connected to any sewer service. And that's kind of what I was trying to say in the last slide. So you have 17 million people that do not use a sewer service toilet. And you know, it sounds like, well, they should just make a sewer service, and that's very difficult to implement that kind of infrastructure in a place that does not have that. So the lack of toilets and sanitation facilities is a main reason for a lot of the polluted rivers, and you will have a video on this in your module. I'm not going to do this one. And the Salton Sea. The Salton Sea is a great example of a local issue. Some of you might not even know about the Salton Sea. It is California's largest inland body of water, and it was once a highly sought after place. I mean, you can't really see, but this picture here shows in the late 50s, it was really a place in 60s to go, and it was like a resort area. You had celebrities go there, and it really happened because of a kind of like a mistake. In 1906, the Colorado River banks broke and overflooded this area, and it filled up this area, and now they called it the Salton Sea. So it was really fed by agricultural runoff, and this is it's a man-made lake, not technically. It used to be a wonderful vacation spot, and it was accidentally created because of irrigation that was dug too deep, and it filled up and became a recreational lake. However, today you have water that is evaporating. You don't have that inflow of water anymore, and so as that water begins to evaporate, it leaves behind the lake bed, this toxic lake bed. And it's toxic because it was filled up by agricultural runoff. And so what's left behind is kind of like this, almost like this very fine powder dust that is full of things like heavy metals, mercury, arsenic. Now, as the winds kick up, that dust goes into the air, and it goes into the surrounding communities. So this is a political, a social, environmental, and economic issue. Like the way to solve this is to keep that lake bed wet. However, where are you going to get that water to keep this lake bed wet? Not full, but at least wet, because if you keep it wet, then that toxic dust is not going into the air and into the communities and causing cancers and asthma and things like that, right? So is there money to keep this area wet? Is there water? And you know, there is not a lot of I want to say, like, people don't really care because the communities surrounding this area are communities of marginalized communities, lower income communities, communities of people of color. So there is really less interest to protect those communities. If it were an affluent community, it might be a different story. It might be. Okay, so there will be a video for this too and explains it a little bit better. But this is a great example of a local issue. And almost kind of the same thing happened in, oh, that's just kind of what I went over. Can't go back now. In Mono Lake. So you have Mono Lake, which was full, but we removed too much water. And they keep it wet too. So there's sprinkler systems to keep all that dust from going into surrounding communities. So I'm looking at Mono Lake here, okay? And then this is all the different places that we get our water from here in Los Angeles. We have some access to local groundwater. You have the Colorado River Aqueduct. Why can't I say that right now? You have the Los Angeles Aqueduct and the California Aqueduct. So a lot of the water we get our water from is a lot of the places that we get a lot of our water from the Owens Valley here. So this is where a lot of our water comes from. We do not have our own water. It is water from California, but we did divert a lot of the water from the Eastern Sierras here down to Los Angeles. And a lot of people, and a huge part is the Colorado River too, comes from over here. A lot of people will argue and say, you know, back then, a lot of these Northern California people hated Los Angeles because we diverted their water. We emptied out Mono Lake and we built this Los Angeles Aqueduct. So if you ever seen, what's that movie from the 50s? That black and white movie. China something. Oh my gosh. Brain fart. Chinatown. Chinatown is the name of the movie. It is about California's water wars, and if you've seen it, it is a classic. I wouldn't recommend you to watch it. It's a black and white film. So, but it is about California's water wars. Mono Lake, this is what I was trying to get to. I kind of went all over the place. That's okay. So you have rivers and streams from the snowmelt that filled in Mono Lake. Evaporation is the only outflow. In 1941, surface water that fed Mono Lake was diverted to Los Angeles. And so it really changed that inflow to that lake. And so you don't have a natural outflow, you just have evaporation. When you have that in a lake, the water becomes salty because even if it's fresh water depositing into a lake, that fresh water carries salt, very, very minimal, and minerals, right? So as that water evaporates, it leaves behind its salts and it becomes saltier and saltier. And that's how it's a saline lake, even if it's fed by a natural freshwater river, okay? So it's kind of it's not really the same as what happened in Salton Sea, but they're keeping all that dust from kicking up into the air by keeping Mono Lake irrigated. So there's these huge sprinkler systems in some part of the lake to keep that dust from going up into the air. So that would be the solution for Salton Sea, okay? And I think that was it. And you will have, the next slide does have